In this video, we'll continue our discussion of conservative vector fields and doing a line integral through a conservative vector field. All right, so this is like the problem before. We're finding work. First thing I do need to show is that it is conservative because it doesn't say anything about it being conservative. And remember, this means work regardless. We don't have a symbol showing that C is conservative. Right, so I need to figure that out. The partial with in respect to x is going to be 2x e to the 2y. M with respect to y is going to be the 2 comes out of the chain rule, and I got x e to the 2y. Okay, they're conservative. So F is conservative. All right, so we run through the same method. We'll say then here. Then sorry, my brain. The gradient of phi is equal to f, which is equal to the partial of phi with respect to x, partial of phi with respect to y, which is equal to mn. There we go. That means we can work backwards. So phi of xy is equal to the integral of phi partial with respect to x dx. Well, that's just m. So I'm going to replace it with m there. Okay, putting an m there, we got x e to the 2y dx. Right, and then we're going to take this derivative, or integral, sorry, 1/2 x squared e to the 2y. Plus, and then we have an h of y, because we could have had a y constant in our phi. Taking the derivative with respect to x would have sent us there. Okay, or would have gotten rid of that. That's a constant. It would have went to 0 if I would have taken my partial with respect to x. All right, so I like to rewrite my phi at this point. Phi xy, because I'm going to do something with it right now. 1/2 x squared e to the 2y plus h of y. Now, we can take partial of phi with respect to y, and we just do it with that function there. The 2 out of that e, 2y, that's the only function there. Everything else is a constant. The 2 comes out, cancels with that 1/2, leaving me with x squared e to the 2y plus h prime of y. Okay, if you remember, we'll take a look here that this phi with respect to y is equal to n. So I'm going to set this equal to n. Our n, if I scroll up just a bit, is x squared e to the 2y. It's that convenient thing that seems to work out quite a bit for us. That goes away. So h prime of y is equal to 0, which means h of y is just some constant. So now, or I guess we could say thus, we have phi. Phi of xy is equal to 1/2 x squared e to the 2y plus c. Now we can use the theorem, since it was conservative. We know, so thus, or therefore, we could have done that. The line integral through the conservative vector field f dotted with dr, which will give us work, is equal to phi of, and I forgot the points, I can look at my notes, it was -1, 1, minus phi of 0, 0. Right, if we just plug these into the function that we just came up with, right, we're going to get 1/2 e to the second power, and then minus, that's just going to be a 0 because of the x. So the work here is equal to 1/2 e squared. We don't have units. We never discussed units in our problem, so we just leave it there. There's our work.